question 6, we have light bulbs and the lives, so how long the light bulbs last. That's our random variable. That's normally distributed with a mean of 750 hours and a standard deviation of 50 hours. So on average, these light bulbs last 750 hours. Standard deviation is 50. Okay. So for part A, we want to find the lifetime of a light bulb such that only 2.5% of the bulbs live longer than X. So in other words, we want to find the value of X such that the probability that you live longer than that is 2.5%. 2.5% is 0.025 in decimal form. So we want to find such an X. So we know that the area to the right of our value is 0.025. And so if we want to find that z-score, an area to the right equal to 0.025 means that the area to the left is 1 minus 0.025. Let's see, and what's 1 minus 0.025? That's 0.975. So we know that the area to the left is 0.975. So let's find the z-score corresponding to an area to the left of 0.975. To do that, we'll go down to our z table, and we want to find 0.975, or as close as we can get. Okay. 0.975, I'm going to look here among the probabilities / areas. 0.975, wonderful, we found exactly that value. So an area to the left of 0.975 corresponds to a z-score of 1.96. So that tells us that z equals 1.96. So now we have our z-score. We just want to put that in terms of our original random variable, which is the lifetime of a light bulb. So remember, to convert from z-score back to x, we simply rearrange this formula and get that x equals mu plus the standard deviation times z. So we know that x is equal to our mean, which is 750, plus the standard deviation, which is 50, times our z-score of 1.96. I can plug this equation into my calculator. And 750 plus 50 times 1.96 is 848. So the value of x, such that only 2.5% of these light bulbs live longer than that, is 848 hours. Let's move to part B. So part B, again, we're going to call our random variable x the lifetime in hours of a light bulb, and we want to find the value, that lifetime, such that 80% of light bulbs live shorter than that. So in other words, we want to find x such that the probability that a light bulb lives shorter than that amount is 0.80, 80%. So we know that the area to the left of our value of x, area to the left is 0.80. So let's look up 0.80 in our z table and find the corresponding z-score. 0.80. Let's see if we can find that. I see 0.87. Okay, I think this is the closest we're going to get 0.7995. That corresponds to a z-score of 0.84. Now let's convert z back to lifetime of a light bulb, x. We know that x is equal to mu plus sigma z, which is equal to 750 plus, what's our standard deviation? 50 times 0.84. If you plug this into your calculator, you should get 792. So 80% of light bulbs live shorter than 792 hours.